Hello, Algebra 2 students, and welcome back to 9.5. This is day 2, and we're actually going to get into graphing rational functions. Last class, we spent a ton of time talking about 4 things, okay? Specifically, the x-intercept, y-intercept, vertical asymptote, and horizontal asymptotes, okay? And right now you need to pause the video and you need to get all of this down, right? All of this example, including my little graph over here. Okay, I need all that down. And then you can see that I need x-intercept, y-intercept, vertical asymptote, horizontal, domain, and range. Okay, so pause the video and get that stuff down. Okay, now that you've had a chance to get the problem set up, I want to go through, and the first thing I want to do is do exactly what we did last time, which is find the x-intercepts. Well, I take the top and set it equal to 0. Okay, well that's 5 then equals 0. I don't think that ever happens, so that's not applicable. Then I move on to the y-intercept. Well, how do I find that? I plug in a 0 for x, right? So if I do that, what would I have? I would have a 5 over 0 minus 4, which is 5 over negative 4, which is negative 1.25. Again, you have a calculator. Feel free to convert these to decimals here on the graph. Vertical asymptote, well, that's the bottom equal to 0. But what's the bottom? That's this. That would be this thing here equals 0. Well, if I solve that, I get x equal to 4. So I just have one vertical asymptote. And finally, we have a horizontal asymptote. Well, how do you do that? Well, you take the degree of the top, which x to the 0, so it's 0 compared to the degree on the bottom, which is 1, and that's less than. When I do that, I look at the cases. This is case 1 from last class. Oh, then that's y equals 0. Okay. Now let's graph these, right? It does say in the directions to graph the asymptotes. So I had y equals 0. That's this line that I'm drawing here, this dashed line. I draw it dashed because we cannot hit it. We can't cross it. And then and then the next one I have is a vertical asymptote at 4. Okay, well that would be right here. So I do my best to draw free-handed, right? Straight lines here. And there's my vertical asymptote. Okay, and what happened here was when you're looking over here at the graph, you can kind of see that the vertical asymptote cuts it, and it creates a left side and a right side. Okay. Now, this is a function, so I don't care about necessarily this y equals 0, this green line that cuts it into a top and a bottom. I only care about a left versus the right. Because I care about it, they could be doing different things in those spots. So I make actually two. I'm making 2 tables. And I need 3 points for each table. Okay, 3 points for each table. Now, this next part you're going to want to pay very close attention to here. What made a left and right side? That was this purple line right here. Hopefully you can see my cursor. Purple line here, right? So what is to the left of the purple line? Well, it's at 4, so to the left of that would be a 3. Then the next one would be a 2, and then a 1. Those points are to the left. Well, what would be then to the right of the purple line? Well, that would be, what, 5, 6, 7. So I go 5, 6, and then a 7. Now is a great time to pause the video, really make sure you understand how we got those numbers there. All right, now, if I know that x is 1, how am I supposed to find the y? Well, you take that 1 and you plug it in. Let me get this stuff out of my way. We take that value and we plug it in right here. So for the very first one, right, I would have a 5 over 1 minus 4, which is 5 over negative 3, which, okay, I don't want that. I'll show you one time in the calculator how to do this thing. So I would have a 5 divided by, even if I wanted to do the negative, I could. That's negative 1.67. So I plugged in 1 and I got negative 1.67. Then I just continue. I take this 2 and I plug it in. Well, if I plug in the 2, right, again, I'll get this out of my way. You should have plenty of room to keep working. I'm taking that 2 and I'm plugging it into this spot over here. So that's 5 over 2 minus 4, which is 5 over negative 2, which that is negative 2.5. Okay, then we just keep going. If I plug a 3 in, I would have 5 divided by 3 minus 4, which is 5 over a negative 1, which gives me negative 5. Okay, now this is the left side. If I take a second and we just plot these points, right, I got these points right here that I can plot. So I have 1, negative 1.67, so that'd be like right here. And then I had 2, negative 2.5 right here. And then I have 3, and it was a negative 5, which would be right here. Okay, now you can kind of see that this thing clearly is like bending, right? Like it's gonna get closer down here to my line, right? Like it's gonna bend. Yeah, that's a terrible drawing. Let's try that again. Right, like this is gonna bend and it's gonna get closer and closer to my purple line. But what happens here as it comes up? Well, remember, we got a y-intercept of 0, negative 1.25. So this point is another one that we could have gotten from right here. Well, look, it's like it hits here and then it starts curving. And it's like attracted to the horizontal asymptote. There is the left side of that graph. It's kind of like an almost pushed out U. Okay, let's see what the right side does then. So I take this 5, and now I'm doing the same thing that we did before. Okay, I'm doing the exact same thing before. I'm taking that 5, which give me a different color. What do I want to do? Let's give me, yeah, this will do well. So I'm taking this 5 and I'm plugging it in for my x. So I have 5 over 5 minus 4, which would be 5 over 1. Oh, well, that's 5. So I put my 5 right here. Okay, well then let's do the 6. So then I have 5 over 6 minus 4. Well, that's equal to 5 over 2. We did that before. We know 5 divided by 2 is 2.5. Then finally we have 7. Well, that's 5 over 7 minus 4. Well, that's 5 over 3. We did that earlier in the calculator. We know that's 1.67. Now I have 3 points on the right side. Well, let's plot those. So I'll go to 5, up to 5. 6, 2.5. 7 was 1.67 right here. And then you can kind of see what's happening, right? This thing is turning, right? So it comes down from up top here, gets to here, and then it starts turning. And then it's going to approach that green line, but it will never hit it because, of course, it's an asymptote. And there you actually have your very first graph. Okay. If we were to do the domain and range, right? How far to the left does the graph go? Well, the graph goes forever down here on this blue, right? So I'm on the blue. It's pushing to the left. Well, how far to the left? Well, it's going to negative infinity. Then it travels until it gets to the purple line, which is at 4. It can't touch 4 now. This is different than what you've seen, right? This is a parenthesis. It can't touch 4. It gets stopped right there because of the vertical asymptote. Now, after that, it makes a jump, and it jumps over here to this orange. Well, remember now, it jumps over to the orange. The orange top part, it's getting close to that purple line, so it's right on it. Well, what's it at? 4. It just can't touch it. Then it travels how far to the right? Well, infinity. And there's our domain. Okay, there's our domain. Now the range, we could do something similar, right? How low does this graph go? Well, the blue down here states that it's going down forever. Oh, okay, down forever. Negative infinity. Then it climbs until it hits our green line. Well, where's the green line at? 0. Hits 0. Can't touch it now because the green is a asymptote. Then it picks right back up at 0. And how far does the orange climb? Well, let's look. It goes up forever, which means infinity. There we've done our very first one. Okay, there's our very first one. One thing you can do is you can have the calculator help you here. Okay, if we go to the calculator, where did we graph before? Well, we graphed by hitting y equals. So let's hit this y equals button, and we're going to type in our graph. There was 5 over, so 5 divided by x plus, no, it's x minus 4. What did I teach you last time? Well, you hit zoom, then it's always 6. And then the question is, does this graph look like our graph? And if I'm clever here, maybe we can see both of them at the same time. Right, like look at the graph over here on the left, that's ours, and then the graph on theirs. It looks pretty similar, right? Now this is kind of cool. Of course, you can't see points on the graph. What you can do is you can hit second table set, okay, which is the window button. Here, you can actually tell your table where to start. You want to start your table right where the vertical asymptote was at, and ours was at 4. Next thing we want to do is after you have 4, you want to count the table by 1. That's what this thing right here is. Okay. And then you hit second graph, which brings up the table menu. And you can see that it'll say an error. You should anticipate that because we can't graph that spot. That's why we drew that vertical line. Okay. This error right here is because of this purple vertical line. That's our vertical asymptote. So here when we're looking at it, oh, I have 5, 6, 7. Are those the same 5, 6, 7 that we had before? Look at our table here. 5 was 5. Oh, 5, 5. 6 was 2.5, 2.5. 7 was 1.67. We got those same things. If you wanted to know where 3, 2, 1 is at, just click up. And there you'll see that we actually have all the same table values over here in ours. Okay, and that's a quick way to transfer your table. All right, so time to do another one. We're going to do this one here. Okay, we have this one here to do. And then I actually am done with this video. Okay, so it shouldn't be too much longer. It's at 13 minutes now. Okay, the last one we had to go really slow on. This one here, hopefully we can pick up our pace a little bit. Okay, so here we have graph. It looks like the same direction, same setup. You should pause the video right now and get this set up. All right, now that you've gotten that all set up, first thing I want to do is I want to find the x-intercept. Okay, x-intercept, I take the top and I set it equal to 0. So this is 4x minus 3 equals 0. That's 4x equals 3. That means my x value is 3/4. My y is 0. There's my intercept. The y-intercept, well, I take zeros and I plug them in for x's. So this is 4 times 0 minus 3 over 2 times 0 plus 6, which is negative 1/2. So that's 0, negative 1/2. Onto the vertical asymptotes. I take the bottom and I set it equal to 0. Well, the bottom is 2x plus 6. So I get 2x equals -6, which makes x equal -3. Oh, okay, x equals -3. And we get to the horizontal asymptote. Well, I compare the numerator to the denominator, the degrees. Check it out. The degree up on the top is a 1 here, and the degree on the bottom is a 1. Oh, well, it's 1 equals 1, which means I take the a value, which is 4, divided by the b value, which is 2. So I get a 2 there, and that means that the horizontal is at 2. Well, okay, we got this stuff. Let's graph it now. So I got y equals 2. Again, dash because we can't touch it. My vertical one was at x equals -3. Okay, yeah, that's a pretty bad line, but you can get the point there. This created a left side and a right side. Okay. Oh, left, right. Okay, I gotta get this stuff out of my way. I don't got enough room. I need now a left and a right XY table, and I need 3 points each. Okay, well, we've done this. Again, we've kind of done this already, guys. Here, it gets split at -3. Well, what's to the left of -3? Well, it'd be -4, -5, -6. Well, what would be to the right of -3? I would have -2, -1, and 0. Okay. Here, in this example, I think instead of plugging them in, I'm going to let the calculator do it. So I need to kind of take a mental screenshot of what that is, and we're going to plug it in the calculator. So I go to y equals, clear it out. Now I just got to remember what it is. Here I see a 4x minus 3. That's on top, so I need parentheses, 4x minus 3. Close your parentheses. That's the whole top, divided by the bottom. Okay, parentheses, what's on the bottom? 2x plus 6. 2x plus 6. Close your parentheses. Top divided by the bottom. Notice I use the parentheses. We hit zoom 6 always. And we see right here on our graph 2 like parabola looking things. Now, as you're looking at it, right, if I asked you to draw a horizontal asymptote, like ours was at 2, right? That's a bad color. Let's get this one. That's where you'd try to draw it. Well, remember, that's at y equals 2. We already found that. Oh, well, what would be the vertical one? Well, it looks like on the graph, it's like right here. Well, that's at x equals -3. We already did that one, right? If we were to go back and look at ours, we should see those things, right? Well, if we go back, here we already have them, right? We already have those things. So it does look like it's making sense. All right, well, then I need my tables. Okay, so I start by hitting second window for the table. I want to start the table. Again, right here is what I'm talking about. Give me a decent color. This, where do I want my table to start? I want it to start at the vertical asymptote, which in our case, it was x equals -3. So I needed this number right here to be a -3. I want this one to stay there. So I change this to a -3. Keep the 1. Next I hit second, and then the graph over here brings up my table. We see an error. We see this arrow right here because that is a vertical asymptote. That's why we drew the dashed lines, okay? That is why we drew them. Now, I want to see all the tables, so I need to go up. I need a -6. These now, okay, when I'm going to transfer this onto my paper, these values are on the left, And then these values down here are on my right. Okay, now would be a great time to pause the video and get that copied down. It's really simple. So if I'm going to copy these down from here, I need to remember, so I got negative, or I got 4.5. And of course, it does matter which one I'm writing down, right? This was 4.5 here. 5.75. 9.5. And then on the other side, at my -2, I had -5.5, -1.75, and 0. I shouldn't even need the calculator for that. It should be -1/2, because we found that right here, which of course it's backed up by that. Okay. Well, now it's just a matter of plotting those. Okay, I'll try to do these points over here in green, and I'll do the other ones in blue. So I have -4, 9.5. -4, 9.5. Then I have -5, 5.75. Yeah, almost to the 6, right about there. Looks good. And then I got -6, 4.5. And now you can kind of see what's happening, right? Like, it appears that it's bending just kind of like this. It kind of got sloppy there at the end, but you can kind of get the gist there. It's not too bad. Then the other one, I said I was going to do in blue, but I think I'm going to change it up. I'm going to do this one in red. So this is -2, -5.5, -2, -5.5, which would be right here. -1, -1.75. And I have 0, -1/2. Then you can kind of see what's happening here, right? Like, it's here tight, then it starts to turn, it goes out here. Okay. And of course, we anticipate it looking like that because when we look at the graph, we see the same thing. Okay. Now we're almost done. We're almost done. The only thing we got left is the domain in the range. Okay. The domain deals with this vertical asymptote. It should always be everything except for that. Notice how I leave it out. Right? I know it's going to go from -infinity all the way until I get to the asymptote. Stop. And this U represents a jump. Jumps over, it starts back up right where it was almost, then it goes forever. Same thing with the range. I have -infinity to 2. Jumps right back to 2 to infinity. And there is your 9.5 graphing rational expressions. We are going to have a test, okay, a 30-point test over just 9.5. Okay, so make sure you're coming in and you're asking questions if you don't understand it.